Dear students, hope you all great. Today we are going to take Newton's second law. Newton's second law of acceleration. The acceleration of an object is a direct proportion to the net force. So acceleration direct proportion to the net force acting on the object, and inversely proportion to the object mass. Acceleration inversely proportion to the object mass. So when the mass increase, the acceleration will decrease. When the mass decrease, acceleration will increase. So net force equal mass times the acceleration. Net force equal mass times acceleration. Net force represents the sum of all external force that act on an object, or the net force. The more mass, the more force is required to obtain a given acceleration. For example, the net force is equal to the mass of the body times acceleration. Net force equal mass times acceleration. Two people pull a 15 kilogram cart, so this is a mass. What is the acceleration of the car? The force that act, or two forces that act on this cart will be 200 and 300, but in opposite direction. So to get the net force, so 300 minus, to get the net force equals 300 minus 200, as it in opposite direction. So the net force equal 100, and we have mass, so we have force and mass equal 30 kilogram. To get acceleration equal net force, which is 100 divided 30 divided kilogram divided mass. So the answer will be 2 meters per second square. Look at second example, which is very important. If we have two forces acting on an object but with an angle like 30 and 60. Two forces act on a 40 kilogram. So 40 kilogram is a mass, as shown in the figure. But we have here two forces acting on this object with angle 30 and 60. First force equal 100, second force 174. First, we should divide these two vectors, the first force and second force, into x and y direction. For example, first one here with angle 30 divided into x. This is the x direction and y, and also first one force 1 x and y. To get this x component, to get this, which is, for example, f1x equal, we should multiply 100 force by times cosine 60. If I want to get x component for f2, so f2x equal 174 times cosine 30. If I want to get the y direction, here f F2y, so F2y equal 30 equal 100, sorry, F2y equal 174 times sine 30. If I want to get the y component y component in F1, F1y equal 100 times sine 60. Look in the solution. Net force equal mass times the acceleration. We divided F1 into y and x component. Look, F1 here into y and x component, and also F2 into y and x component. To get the F1y, we should multiply 100, which is F1 times sine 60, and F1x equal 100 times cosine 60. In the second angle, we divided into x and y component to get Fy 174 times sine 30, which is equal negative 87. Second, to get F2x equal 174 times sine cosine 30 equal 150. So to get the net force, we should add F1y plus F2y, which is equal 0. 87 plus minus 87 equals 0. And F1x plus F2x, which is equal to 100. So the net force equal to 100. To get the acceleration, equal net force divided in mass, we have a net force 200 divided 40 equal 5 meters per second. That's it. Thanks for watching.